Okay. Pressing on. I know this step now. Now, my instinct at this moment is to position a little cursor and to just imagine the origin. I'm not getting my pen out for this, but if this is a close-up of this larger example, position a little cursor in the correct point there, just off perpendicular, half the length of the little notches I'm going to draw, and have that the thing that I bounce off along as many notches as I need to draw, and with a knowledge of the step required to make that. Now this is why I think, because is it not something really simple like the sine of an angle is equal to the cosine of its perpendicular or something like that? You know, these half-remembered things I have from learning maths, what I did learn. I'm going to have to figure out the step anyway, so why don't I just say local CA for cosine of angle. Oh, I hate my typing. Equals cos of angle, and SA float equals the sine of angle. That CA times that SA times that. And I say, what's the problem? Okay, got you. Okay, then I say local notch vector g vector equals gvec. What is this? I want to say something like what is the mark on a ruler called? Like, you know, because that's kind of what these things are going to look like, the marks on rulers. It's an indicator or something, but I want a shorter word from that. I'm just going to call it notch length. Float equals 7. GVec, I'm going to make this weird guess, and it's going to be embarrassing, you know, if it just turns out to be rubbish. Comma CA times notch length. Oh gosh. At any rate, we'll get something funny being drawn, and that's sometimes just as good. So now I know a little vector which describes the step along a notch, or at least I'm making up a vector, and I'm saying it describes the step along a notch. The idea being perpendicular to this, I can actually figure it out anyway if this turns out to be rubbish. It'd just be nice if it was true. Now, what is this step? The step that goes from the center to where I want to start effectively drawing notches from. It's half a notch. If this is the full step of a notch, which maybe it is according to this, then this is negative half a notch. So now I'm gonna, what? Sine. Now I'm gonna set up a start position. All these locals, many of them really are going to become globals, and probably a part of Snap, because a lot of them are going to be used. Let's see, local cursor. This is how I think of it. Cursor vector equals gvec. Center transformed x, comma, center transformed y, but not that. Center transformed x minus notch vector x divided by, I'll say times 0.5 because I like that better, minus notch vector y times 0.5. Now, local steps assignment, the famous Twitter account assignment, equals distance, it equals the integer of distance divided by size plus 1, I think, because what I want it to do is draw 1 for every step length along the line and 1 beyond the end of the line to show where it would go if you dragged it out there. 1 for every step along the line and 1 for the step beyond the end of the line. The integer of distance divided by size, 1, 2, 3, so let's say this distance is 3.5 and the size is 3, then the answer is 3.5 but integer just gives 3, so we get 3 plus 1. Right. Oh, I could just do 0, 2 steps, couldn't I? And get rid of the plus 1 probably, could I? Don't know, I'm not going to bother just now, I'll see. 0 until steps. Now, at each step, I want to G-line draw. What on earth is the chances I've got this size? Curse x plus notch v x, comma, curse y plus notch v y, comma, oh, sorry, should start with curse x, curse y, curse x, comma, curse y, comma, curse x plus notch v x, comma, curse y, comma, t1, comma, c av, comma, blend mode alpha, and draw the last pixel. Now curse add step v. Is that allowed? No idea. I think so. Surely. Don't. Okay, hang on. A vector has nothing named vector name C. What on earth? Oh, there. I'm getting baffled. Okay. X, Y, X, Y, X, Y. Curse is a vector. Don't tell me. A vector doesn't add. It doesn't. Should I just take this as the opportunity to do an operator overload? I should, shouldn't I? Embarrassed to say that the only way I would know, the quickest way I know to look up an operator overload is just to look up the monkey code and basically copy it. I hope that's not terrible, but you know, it is basically, what can I say, types. Where am I looking? There's many modules to hunt through. looking for? Oh yeah, I'm looking for vec, so it's geom, I think. Vec 2. Operator 2, okay. Vec 2 type 2c, okay, yeah, right. I want this simple operator stuff. These divided, so it's operator times colon vec2 return u vec2. Okay, I see. It's because it's a struct. I'm not going to do that. I feel better because I'm not just going to have to lift directly because I don't understand how to use operator overloads, but I will immediately do an add and subtract here. And it's going to add it to the vector. And I can see that I'm not very careful above. Usually I do build in that sort of safety, and I will do that, but no, I won't. I'll just abide crashes if it's going to happen. X plus equals Vx, y plus equals Vy, and then set, and these I'm returning the self, so I'm not going to do that either. I realise it might allow for daisy chaining things, and maybe I will come back and find myself doing it, but I don't find myself daisy chaining things much. I must admit, I find that to be a thing I get confused by. There are certain times I do, and certain times it's really useful. And maybe I will find myself. Why do it that way? Maybe I'll find myself coming back and changing that. Let me just quickly check my time. 12 minutes. I'm going to keep doing 15-minute chunks. Just anyway. VG vector equals null. I shouldn't even bother saying it equals null, should I, under the circumstance? X times equals V. No, not plus equals times equals Y times equals Vy. And I'll add in a divide, and I'll add a scale, I think. Method add. And I just realised. No. Divide by VG vector equals null. I should just stop even typing the null, shouldn't I? They would look better if I'm not going to do anything about divide by equals V. If I'm not going to do anything about getting a null, I should just not bother. Okay. Sorry, son. So I was going to say, if I'm getting the length, then I know how to set the angle, don't I? Or at least to make a unit. I'm going to make this thing called make unit, and probably I will later learn and also local L float equals length, x equals, or it's like x divided by equal length, is it? Is that how it works? And y divided by length. I have no real idea how this works, I realise. Okay, these are the things I have to go and look up and try and understand better and not waste everyone's time going, what is a unit vector? It's probably not this, is it? It's something different. This is like a something else. Okay. Right. So for the time being, anyway, I have add, subtract, divide, multiply. So at least I can do some things easily, like add step v. And that should step along and draw a bunch of little lines. Loads of things about this I'm super skeptical of, but now, having done at least these two, I'm going to have to get serious about rebuilding this in such a way that they'll actually draw, because I can't run anything just now to test it. So this is all really different to the way it actually is going to be laid out. Well, this isn't, that's got nothing to do with it for starters. This is how it will actually look. It should be called constraints. I always end up making, this is red because I named my declaration up there constraint. In the declaration it's named constraint, and that's wrong, but it should be constraints. According to the way I usually end up naming things, lists end up being plural and arrays end up being singular, because often I'm referring to individuals in an array. So I was thinking about what really needs to happen here, and it is well different. This logic of the number of segments is the number of segments in the path. In selected corners path. This bit. Now I moved that out there, then I moved it back in here. But really it's kind of the number of segments and the position of the corner is totally independent of each other. Like, just right now I'm just about to break all this because that should end there. All of this is gibberish of the highest. And I'm going to ram it out until it bloody gives no error, at any rate. That shouldn't be rammed, should it? Where does this... X, guide color, face... No, okay, I am making a mistake. Sorry, you caught up with me. I don't need that. I've got one end too many. Somehow. Surely not. Where is this coming from? Excuse my... Maybe I've made... Okay, so I've decided by this point angle snap is true, project angle snap is true, right? No. In fact, all of this is not for finished draw. It's just that, like, even among while I'm deciding what sort of this is to do with deciding which what am I trying to say? Which snapping components are active, which are actually on the screen. It doesn't belong in finished draw, and it doesn't have this structure. So both of those things are wrong. So the first thing I'm going to do is I'm going to figure out where it actually belongs. I've rammed it all out, and that doesn't matter because all I really need to know are some of these details, because actually the structure is quite different. In fact, well, I won't figure out where it belongs first. First off, I will just look at this little bit of the logic, because numsegs is to do with vpause. So I'll leave vpause there. Oops. for just a second I'm going to think about where this piece of code is going to be called. At the moment I've got this stuff in because this is the draw function. This is making sure I don't bother drawing a bunch of stuff related to angle and length snaps if they're not even active, or if I don't have a vertex or I don't have anything selected, so there's nothing to place angle and length snaps against. So that's why this is here. It doesn't belong here. Like I said before, by the time I'm at this point in the code, the drawing, actually this is all I want. I want to be referring to my list of constraints and drawing them. This bit also, I'll just rhyme out, it's kind of irrelevant. That bit can stay because I'll keep it going. Just irrelevant. But where will this actually be executed? Excuse me. There is another. This is like the first time in all these hours and hours that I've moved outside of the finish draw bloody place, more or less. There's this work method that belongs to all types of gadget, and the work zone is a type of gadget. It figures out what the mouse is doing. It knows what the mouse was doing last frame, and it says, well, what were you doing, and what are you doing now? And it tracks the mouse through the mouse state variable, which is just somewhere around here. Gosh, I don't know where there, mouse state. And excuse me again. I'll just stay. And it's a little bit clumsy, this, but it's kind of manageable. Normal, dragging, scrolling, move output, scale output. And this other bit of the mouse state, which was added later, none, vert, move output, scale output. So something that I have to sort of decide is, when are the guides technically visible? You can say the grid is obvious, like it's visible either constantly or just whenever the grid snapping's active. But with the other two types of guide, they change not just depending on the values set by their size, but they change depending on the corners adjacent, the corner which is selected and which corners are adjacent. And it's not really just even the corner that's selected. Should it be the case that those guides only appear when the corner is, well, when it's technically, when it's being moved, when you're holding down and dragging it? And I think that they should. I think they should. And at least that's the way I'm going to build it initially. That solves one problem, which is what happens when you move the mouse out the window, because if they're not only active when you're dragging, then they're active once you've selected a corner. So then wherever you move the mouse, or is it that they stick with where you left the selected corner? Suppose they could do that. That's pretty strange though, I don't know. No, I think I'm going to have them switch off. But anyway, what that means is that I know, or at least I kind of have in my mind now, about when those guides appear and disappear. So I have this list of constraints, and I want them I want it to contain the correct constraints moment to moment in the frame. This check position method receives an x and a y, and it figures out which spot you're covering, or whether or not you may potentially make a new spot. Find restraints. Never mind that just now. This is the thing, work. This little bit runs the scrolling. I did have it scrolling by the mouse wheel. I suspect it's because my mouse wheel is so utterly goofed that I couldn't use it. I had to do this hold down the right mouse button, push forward and back to scroll to zoom, which I'm not pleased with, but it's okay. So all this does is, under any circumstances, if the gadget that is the current covered gadget is this gadget itself, you can zoom it with the mouse button. Separate to that, I'll just divide those up, it's a bit of a continuous one. This is what happens to the mouse. I'm going to move dragging, because really it shouldn't be first in the list. Normal should be first in the list, but dragging should be second. Normal is assumed to be that the mouse is just hovering around over the screen. Why that is there, I have no idea. Oh well, no, I do, I suppose. Yeah, I kind of have to do it that way. This work method, sorry, I'm getting lost in thought again about my weird system. This work method is part of the GUI system. It's kind of part of it from a more old-fashioned version of it than it should exist as. The GUI was originally written in Monkey 1, and I used it a lot, and then I moved to Monkey 2 and updated many parts of the GUI system to use Monkey 2's features, namely and most importantly function pointers. But the work method was a kind of hangover from the way it worked prior to, well, when it was written in Monkey 1, where function pointers weren't available, but there were a lot of other things, including inheritance, which is not inheritance, interfaces, which is what I used to do the sort of interaction between the GUI and outside code. And work is one of these functions which doesn't really have a good place in the modern version of the GUI as I'd like it to work. But it gets called from the GUI's internal functioning for every gadget that is involved in an event, basically. Actually, it sort of comes from a time from before my GUI was altogether using events. Because it used these interfaces, it was just a bit different. I can hardly remember, to be honest. But one way or another, most of the GUI needs rebuilt to stop using this work method and to have a bunch of sort of event response methods. It would be a lot cleaner and nicer if it did. It's just another part of that larger overhaul for later. The main reason I'm saying all this is it's what I can expect to be going on, or sort of what I should expect from the information that's available when work is called, which is to say stuff like this. The GUI's internal brain, which is actually just the gadget class, which needs to change, but never mind, is, by the time this is called, it's all updated with the most up-to-date information about the state of the interface, the covered gadget, and a bunch of other things, like the position of the mouse on the face of the gadget. Not that I use these things much. Just other things. I forget all the little details. And I forget also why I went off on that tangent, except to say that is kind of This is it integrating with the GUI, I suppose, is all I'm trying to say. Just trying to clarify it in my mind. Like, this method is called as part of the GUI's work. Anyhow. Maybe I'm just trying to distract myself from the fact that this is a nasty little thing I've got to think about. And all it is that this checks to see what happens if the mouse is in normal state. Because just because it comes into the frame in normal state, and I say into the frame, I mean the frame of animation, doesn't mean it's going to exit it. It checks to see that the mouse is in fact over the gadget. I suppose that's kind of what I was getting at. This method could be called even though the mouse isn't over the gadget, because my GUI works in mysterious ways. Like, this work method will not necessarily be called every time. It'll be called when the gadget's involved in an event of some sort. So not all gadgets are having their work method called every single time. It's whenever the mouse is over the gadget, the mouse enters the gadget, exits the gadget, presses on the gadget, releases it, but also if it presses on it and moves off it. As long as the gadget is held, then this work method is called. Also, as long as the gadget was the last pressed gadget, this work method is called. I do remember the point of all that ludicrous chat. It is complicated when I think about it, and probably not that elegant. But the point is, if I move the mouse onto the gadget with the mouse button raised, I am in M-normal state. But if, whilst in M-normal state, it senses that the mouse button is pressed down, it looks to see if covered vert has a value. Sorry, I should have started with this. Check position. The first thing I do, after making sure that the mouse is inside the gadget, and I do have to check that because this could be called if someone had moved into the gadget, held down the mouse and moved out of the gadget. But actually, that wouldn't quite... yeah, it could have happened. Anyway, check position gets the position of the mouse in the world and updates covered vert, covered vert and covered corner. So let me just have a little quick look at it. Yeah, covered vert equals null, covered corner equals null. So at the start of check position, it just blanks them. Then it goes through all the corners, all the verts, and updates the details of a selection of like references, you know, covered. I hate to say this, but it's all over the place. Covered corner and covered vert are stored as part of the recursor program. They actually make use of those things at some points in there as well. The recursor program is probably going to make use of these as well, and yet here they are. Anyway, with a combination of the covered vert, the mouse state, and the covered control, because the mouse can, you know, as the program progressed, I realized it's not just verts the mouse can cover, it could also be move and scale output controls for controlling the rectangle of the screen, or well, not the screen, but the frame of the image that'll be finally rendered. So once check position, it's implied, like I say, when you're in M normal, that it's entered this frame with the mouse button up. But then if you press mouse button middle down, mouse state equals M scrolling, which means you're pulling the viewport around. button left down, then it looks at covered vert. If covered vert got set to something inside check position, then selected vert becomes the same as colored vert. Selected corner becomes covered corner. The corner and the vert are slightly distinct, you know. The vert is within the corner, but I want to know which corner is covered quickly without having to look at the vert, then hunt through the corners to find the vert. Mouse state gets set to dragging, and I refresh the GUI. Why do I refresh the GUI? Don't really know. There's probably some good reason. Refreshing the GUI means updating all the information that's inside each of the gadgets at the left hand side. If there's not a covered vert, have a look and see if move output or scale output are covered, or have a look and see if that's short for potential corner predecessor, which is another terrible name, but that checks to see if it's in a this gets set inside check position. If no vert is covered and the move output and scale output aren't covered, then it checks to see if your mouse is near any of the lines, and if it's near enough without covering anything else, then a potential corner is, you know, on the cards. A corner is potentially made. So this reference gets set to the corner prior to the potential corner on the line. I'm just going over all this because I don't know why. It's because I'm trying to remind myself, where do I build in the point? And it's just about here. The point where I say, how do I update my, you know, what is, I need to update my list of constraints. And as I think about it now, I think actually using a full list of constraints, maybe it's okay. It's just maybe I should avoid adding the grid to the list of constraints, because I'm sorry to say I've gone well over time again. I'm working my way through this. I know it's really boring. It's particularly boring when I can never run it to check. And a lot of me at this moment has just been kind of talking my way through the changes that I need to make to get this logic that I built inside finish draw. The logic that is there. Like just that, basically, when it came down to it. Oh no, not just that. All that as well. That logic gets moved to its correct place, and it doesn't really have this structure. This was just about figuring out, you know, all of the things that needed to happen. And let's face it, I didn't exactly get to the end of all the things that needed to happen. But right, for now we'll call it a day again. Bye.